Hey class, today we're going to do some review for exam one. I've provided a study guide for you to use as guidance on preparing for exam one. You'll notice that it has a list of concepts from the four chapters that we've covered thus far. And then when you get down here, you have some applications. Right. So what I'm going to do for this exam is I'm going to help you prepare for the applications that are coming up because the format of these applications are going to be a little bit different from what you got in your homework. And these questions regarding the concepts are going to be in the form of multiple choice. So what you want to do for those is just review the text and make sure you know the definitions of the items on the list, like what is a statement, what is an argument, and so forth. Let's come down here. I gave you some practice problems for the applications, and we're going to focus on three out of the four here. The one that I'm not going to focus on, for this session is the third one, which is has to do with the six argument patterns, starting with modus tollens. The preparation that you got in the homework should be enough, and it's going to be the same format. You're just going to be given an argument, and you're going to have to identify the argument pattern in that argument. Okay, so the other ones, on the other hand, are going to be a little bit different. So, for instance, for this first one, it's asking you to determine whether a given argument is valid or invalid. Now, the format is going to be such, right, that you're not going to have to determine whether it's a deductive or an inductive argument. You're going to be told that it's a deductive argument and asked, is it valid or invalid? So let's take this first problem here. This is an argument, and the question is whether it's valid or invalid. Now, you want to recall the definition of validity, which is that an argument is valid if when the premises are assumed to be true, the conclusion follows necessarily. So that means, that if the information contained in the premises, notwithstanding, its truth or falsity, or bracketing its truth or falsity, is the information contained within the premises such that the conclusion follows necessarily in a way that it couldn't conceivably be otherwise. It couldn't conceivably be false. It has to be true necessarily. So I'm going to show you a way of of testing for some of these statements that allows that you can do so by means of classes. So the circles that I'm going to draw here represent classes. Okay, so I'm going to capture the information that's included in the premises by means of these diagrams. So the first premise says all automakers are computer manufacturers. So what you have in this first premise is the establishment of this information. You have the class of computer manufacturers, and the premise is telling you, look, there's another class which is contained within this class, which is the automakers. And the second premise is telling you that United Airlines is an automaker, right? So that I'm going to draw this X right here. That means that this X here represents United Airlines. It's an automaker. It falls within the class of automakers. So that's the information contained in the first two premises. And now the question is a conclusion necessarily true given this information in the premises? Now, if you can, conceive of it as being false, then it's invalid. But if it is, true necessarily, and you can't conceive of it otherwise, then it's a valid argument. So this is actually a valid argument because it says that United Airlines is a computer manufacturer. So with the information you've been given, you've sort of, were necessitated in putting, on United Airlines within the class of automakers. And then, the other premise tells you, well, all automakers are computer manufacturers. Well, if those two things are true, then it necessarily follows that United Airlines is an automaker. You couldn't conceive of it as being otherwise. Okay, so that argument is going to be a valid one. Okay, so we'll put valid here. Okay, so now let's take this other argument. since some fruits are green and some fruits are apples, it follows that some fruits are green apples. There's actually going to be a couple different ways you can draw the, a diagram, representing this. And so I'll do it both ways. Let's get rid of this here. Okay, so let's take the information, that is contained in these two premises. So the first premise is that some fruits are green, right? So what we're going to do is we're going to draw two circles like this, and it says, that some fruits are green. Okay, so that means that there's, some fruits in here that are green, right? This represents, the intersection between things that are green and things that are fruits. That's the first premise. The second premise tells you that some fruits are apples, right? So you might draw it like this, right? So you have things that are apples here and things that are fruits here, and in the middle here you have things that are both fruits and apples. You can put an X in here. Now notice that the information contained here makes the premises true, but this information does not imply that that there necessarily are fruits that are green apples, right? So so by this diagram, you're showing that that the premise is not necessarily true, and therefore the argument is invalid. Okay, so that's one way of drawing the the diagram. Another way is as follows. I'm going to go ahead and draw three overlapping circles. We're actually going to learn how to do this in chapter 7. But so you have three overlapping circles, and one of the circles is things that are green. The other one is things that are fruits, and then the third one is things that are apples. So the first premise tells you that there are things that are both green and fruits, and that's in the overlap. Okay. Second premise tells you that there are things that are fruits and apples right here. Now notice that that information doesn't tell you that there's anything in here in the overlap between the three things, right? Apples, green things, and fruits. This may very well be empty, right? And so if it is empty, that means that the conclusion is false, even though the premises are true. So you notice that with that scenario, you've come up with a scenario in which the premises are true, but yet the conclusion is false, and that's the definition of validity, right? Whenever you have that, you have an invalid argument. So we've shown two ways in which this argument is invalid. You can also think of it intuitively, right? You don't necessarily need to draw these diagrams. This is just some a way of doing it, but you can think intuitively. Look, some fruits are green, right, and some fruits are apples, right? Those two premises. So now the fruits that are green, that is referenced in the first premise, might be a fruit like a lime or something, right? It doesn't have to be an apple, right? So and then the second one where we're talking about fruits that are apples, right? Okay, and those fruits that are apples are not necessarily green. They might be red. Let's say they are red. So then you don't have in the premises, you don't have the intersection between green fruits and green and apples, right? They might be just separated. They might not have any intersection. So the intersection is not guaranteed by the premises, which is necessary to make the conclusion true. So just thinking about it intuitively would make it an invalid argument. So yet another way, you might sort of think of a scenario, in which the conclusion is true and yet, in which the conclusion is false while the premises are true, which makes it an invalid argument.